Hi everyone. Today we are going to see a simple problem on the Rankine cycle. As you know that the Rankine cycle is the main cycle that is used for the steam power plant. So today we can do a simple problem on the Rankine cycle. This is the question. A steam boiler generates steam at 30 bar 300 degrees Celsius at the rate of 2 kg per second. The steam is isentropically expanded in the turbine to a condenser pressure of 0.05 bar at a constant pressure and pumped back to the boiler. So we have to find the heat supplied in the boiler per hour, determine the quantity of steam after expansion, what is the power generated by the turbine, and estimate the Rankine efficiency considering the pump work. So whenever a problem is given, we have to write the given data. Whenever a problem is given, we have to write the given data. What is the given data? What is the given data? P1. P1 is 30 bar and P2 0.05 bar and temperature, that is the temperature T1 is equal to 300 degree Celsius with the mass flow rate of 2 kg per second. Okay, so we have to find the heat supplied, that is QS, and the quality of the steam, that is Reynolds fraction of the steam, X2, and work done by the turbine, and finally the Rankine efficiency. Okay, so in this Rankine cycle problem, we have to draw the TS diagram first. Okay, so now see here. This is the process from 1 to 2, 3 to 4, and okay, this is the process. See here, the initial pressure is 30 bar, and it is the reducing to a pressure of 0.05 bar, and the temperature, it is 300 degrees Celsius, which is superheated. So 300 degree Celsius. So this is the typical TS diagram for the Rankine cycle. So we have to draw the diagram. Okay. Now, regarding this problem, we have to take the data from the steam table. So the steam table should be accompanied with the Rankine cycle. Okay. So first we are taking the properties of steam from the steam table. What is the maximum pressure? 30 bar. At 30 bar, which temperature H1, that is the superheated stage. Superheated table, we have to take the corresponding 30 bar with the temperature 300 degrees Celsius. We have to take the enthalpy, that is 2995.1 kilojoule per kg. And the entropy is given by 6.542 kilojoule per kilogram Kelvin. Okay. Similarly, at 0.05 bar, we have to find the condition of the steam. So we have to take the HF value, that is 137.81 kilojoule per kg, and HFG2 is 2423.8 kilojoule per kilogram Kelvin. And similarly, SF2, that is 0.476 kilojoule per kg. Here, note the Kelvin unit, kilojoule per kilogram Kelvin, and SFG2, that is 7.920 kilojoule per kilogram Kelvin. Okay. Now we have to take the specific volume also. That is specific volume VF2 is given by 0.001005 meter cube per kg. So whenever you take the data, you have to write along with the unit. Okay, the unit carries mark. Okay, then the process 1 to 2 is said to be the isentropic expansions in the turbine. Isentropic expansion, the process 1 to 2 is the isentropic expansion in the turbine. So we know that S1 is equal to S2. What is the value of S1? Here, that is 6.542. So we can write it here. 6.452. Okay, kilojoule per kilogram Kelvin. And we have to find out the entropy, that is SF2 plus X into SFG2. Okay, and from this condition, X2 can be calculated by S2 minus SF2 divided by SFG2. So that is equal to 6.452 minus 0.476 divided by 7.920. That is the condition of the steam is, the entropy is 0.766. That is the dryness fraction. So the steam has the condition, that is the 76% dry. Okay. So the quality of steam after expansion is, then we have to find out the enthalpy, that is H2 is equal to HF2 plus X into HFG2. So 137.81 plus this is dryness fraction into the HFG2 value, that is 2423.8. So that is the H2 value is given by 1000 joule per kg. Okay. Now we have to find out the H3 value. So the H3 is denoted by HFG2. What is the value of HFG2? See this value. That is 137.8. So we have to consider the pump work. Okay, so we have to consider the pump work to calculate the heat supplied to the boiler, right? So we have to find out what is the formula, that is H4 minus H3 is equal to Vf of P1 minus P2. So that is H4 is equal to H3 plus Vf2. So here it is 137.8 plus 0.00100 into 30 minus 0.05 into 10 to the power 2. So here finally we obtain the answer as 1.140.81 kilojoule per kg. So why we are introducing this term, the 10 to the power 2? That is, we have to convert it into kilopascal. Okay, so that is the parameter we have find out, for we are going to find out is the heat supplied in the boiler. Okay, that is Qs is equal to m into H1 minus H4. So that is, what is the value of m? What is the value of m? That is the mass flow rate that is given in the question. What is that? Is 2 kg per second. Okay, that is a 2 kg per second is given in the question. Now 2 into 2995.1 minus 140.81, that is equal to 5708.58 kilojoule per second. Okay, so this is the answer. And the power generated by the turbine, is, that is Wt is equal to m into H1 minus H2. So that is equal to 2 into 2995.1 minus 994.44. So that is equal to, and finally we have to find out the Rankine cycle efficiency of the plant. So the Rankine cycle efficiency is given by Rankine cycle efficiency is given by H1 minus H2 minus H3 minus H4 minus H3 divided by, calculate all the data, you will be getting 34.95 percentage, which is similarly equal to 35 percentage. Okay, so what is the Rankine cycle efficiency? That is H1 minus H2, that is the pump, the turbine. Okay, from the turbine minus the pump, that is H4 minus H3, that is the pump turbine minus the pump work. Okay, divided by the pump work. Okay, thank you.